Hi, welcome to grade 4, lesson 28. Our learning target for today is I can solve word problems with line plots. A line plot is a special graph that shows the number of times something occurs. So if you're ready, let's get started with number 1. Number 1 says, a group of students measured the lengths of their shoes. The measurements are shown in the table. Make a line plot to display the data. All right, so let me move this up so we can see the whole data table. It says this table shows the number of students and the length of their shoes, and it's in inches. Let's create a line plot to show the information. And a line plot is like a number line. So I'm going to go down here to the very bottom, and I'm going to draw a straight line, and I'm going to put arrows on it because it continues. All right, so we have our line plot. It's a number line. First, we're going to put all of this data, in order from least to greatest. Now, I notice that all of the fractions do not have the same denominators. I have 8.5 here. I have 7 3/4, 7.5, 7 3/4, 8, 8.5, 7 3/4, and 8 3/4. This one and this one and this one do not end in quarters. So the first thing I'm going to do is I'm going to find a common denominator by making them into equivalent fractions. So they all end in quarters. It'll make it easier when we're putting our data on our line plot. So since I want a common denominator for all of these, since all of them except those three end in quarters, I'm going to change them into quarters. And I do that by finding the common denominator. So for 1/2, in order to change it to a quarter, I need to figure out what did I multiply 2 by to get to 4. Well, I multiply that by 2, and the rule says whatever you do to the bottom, you do to the top. So 1 times 2 is 2. So 8.5 is the same thing as 8 2/4. I'm going to do the same thing with 7.5. I want quarters for all of these. So since we want this to be changed into a quarter, I need to find out what did I do to the 2 to change it to a 4. I multiplied it by 2, do the same thing to the top, and 1 times 2 is 2. So I have 7.5 is the same thing as 7 2/4. And we already did 8.5. 8.5 is the same thing as 8 2/4. All right, so now we have a common denominator for all of our data, and I'm going to put them in order from least to greatest. So the smallest one here, I'm going to put it up here, least. The smallest one here would be, well, I have 7 2/4. 7 2/4 is less than 7 3/4. So I'm going to put 7 2/4, which originally was 7.5. So I'm going to use the original numbers. So I have 7.5. And then the next one would be 7 3/4. So 7 3/4. And I have another 7 3/4. And I have another 7 3/4. Okay, so we're done with the 7. So now I go on to the 8s. I have 8 2/4, 8 2/4, and 8 3/4. So we have 8. And then the next one would be 8. I'll go back to the original, 8.5. So that one is used. Another 8.5. And the biggest one is 8 3/4. So now I have them in order, arranged from least to greatest. So that will help us when we go ahead and put them on our line plot. Now, what will the endpoints on our number line be? So we look down here on our line plot, And if I look at my data, the smallest number here is 7.5, and my largest is 8 3/4. I want to find uh, numbers that would include all of these. So since 7.5 is the smallest and 8 3/4 is the largest, I'm going to use the endpoints 7 and 9. So we have 7, 8, and 9. Those are the numbers that I'm going to put on my line plot, and those would include all of the data points that I have. Now, to finish this number line, we need to decide what measurements on this ruler could we use to mark off the length of the shoes. So what is the smallest unit? Well, if we look at all of the units, we changed everything here to fourths. So since everything here was converted to fourths, the smallest unit that I'm going to use is 1/4 inches. So I'm going to label that here on my line plot. I am going to put fourths on my line plot here. So that would be halfway through is a half, and that means then I cut each of these in a half. So that would be 1/4, 2/4, 3/4, and 4/4 is 1 whole. And I'm going to do the same thing here. This is the half. So then I cut these again in half to make fourths. 1, 2, 3, 4. This would be 1/4, 2/4, and 3/4, and 4/4 is 1 whole. Okay, so now I have my numbers all on my line plot. And we also need to label this. What does this line plot represent? So I need a title. And if we go back to our data, the title was that the students measured their lengths of their shoes. So my title would be Students Length of Shoes. So the students' length of shoes. That's my title. That's what the information on this line plot is for. So I do have a title. I also need a label. The label goes at the bottom, and the label down here simply tells me what unit of measurement the line plot shows. Well, all of these, as we could tell from the graph, were all in inches. So our label down here would be in inches. That is our measurement, unit of measurement, and they're in inches. The length of shoe, the length of their shoes are in inches. So inches is our label. And also we can throw in that the data that we're going to put on, the students here, are going to be represented with an X. So the X is going to represent one student. So that's almost like our little map key. Each X is going to stand for one student. So now that we have our title, our label, and our key, now we're ready to put the data on our line plot. So let's go back to see what we had here. We had our smallest one was 7.5, so one student had a shoe size of 7.5. Now remember when we went to 7.5, 7.5 is the same thing as 2/4. So this 1/2 was the same as 2/4. So I'm going to put an X right here. So the 2/4 was the same thing as 1/2. Let me show you. All right, the next measurement was 7 3/4. So I'm going to put 1X here. So we are done with this one and this one. Now we go to the next student, also had 7 3/4, so that's 2. The next one is also 7 3/4, that's 3. We had one student that had 8, one student that was 8.5, and remember 2/4 was the same thing as a half, so we're going to put 8.5 right there. We had another student who had 8.5, and the last student was 8.75. So I want to double check. I had 1, 2, 3, 4, 5, 6, 7, 8. I want to make sure that I have 8 students represented on my line plot. 1, 2, 3, 4, 5, 6, 7, 8. So that is my line plot that represents the number of times that the shoes were measured. So I have my title, my label, and my key. Now we're going to use this information from my line plot to answer the following questions. So question number 2 says, let me do it this way. Question number 2 says, who has the shoe length 1 inch longer than Dickens? So if we go to our information data table, Dickens has 7.75. So let's do it this way. So Dickens has 7.75. And the question says it has to be 1 inch longer. So 1 inch longer means I'm going to make it +1 or add 1 more. So when I go to add these together, 7 plus 1 is 8.75. So which student had the 8.75? So we look at our chart, and that would have been Mary. So 8.75 is 1 inch longer than Dickens, and the answer is Mary. Mary's shoe length is 1 inch longer. Okay, let's go on to number 2, or B. Who has the shoe length 1 inch shorter than Susan's? So if we go to our table, we see that Susan had 8.5, and 8.5 we changed to make it the same with everybody on the chart. We changed into 8.75. So that's Susan. And it says, whose shoe length is 1 inch shorter than Susan's? Well, shorter means to take off. So we're going to have 8.75, and we're going to subtract 1. So if we subtract 1, we're going to have 8 minus 1 is 7, 7.75, and 7.75, if we go back to our chart, 7.75 was Ben. So the answer for letter B is Ben. Ben's shoe size is 1 inch shorter than Susan's. Okay? Because again, this was equal to 7.5. All right, letter C. How many quarter inches is Martha's shoe size? How many quarter inches is Martha's shoe size? So Martha shoe size, according to this chart, is 8.75. So we have is 8.75. How many quarter inches? Okay, so we have 8.75. How many quarter inches long is Martha's shoe size? So we need to know how many quarter inches. Oops, I used the wrong one. Martha is 7. Sorry. Martha was 7.75. I was using Mary's. Okay, so it's 7.75. And I need to find out how many quarters are in 7. So how many fourths would there be in 7? So in order to solve that, I am going to take 7.75 and I'm going to decompose it using a number bond, and I'm going to have 7 whole and 3/4. Now, I need to figure out how many quarters are in 7. So 7 has how many 4/4 in each one. And I also have to remember to add my 3/4. So 7 times 4/4 is the same thing as saying there are 28/4 in 7. Plus I have to add my 3/4. So 28 plus 3 is 31/4. So there's 31/4 inches. 31/4 inches. There's 31/4 inches in 7 3/4. So let me show you again here. I broke the 7 3/4 into 7 and plus 3/4, and I needed to know how many fourths are in 7 whole. So 7 times 4 is 28, and the 28 plus my 3 gave me 31. All right, letter D. What is the difference in inches between Lily? Let me put this back here so you could see. What is the difference in inches between Lily's and Martha's shoe size? So let's make sure we have the right people. Lily's shoe size is 8. Okay, so that's Lily's. And Martha shoe size is 7 3/4. Both of these are in inches. And we want to find the difference, and difference means to subtract. All right, so I cannot subtract 3/4 from nothing, 0. So that means I need to rebundle my 8. So I rebundle my 8 by doing this. I'm going to decompose it into, if I take 1 away, and then that 1 that I have, since this is in quarters, I'm going to leave it as 4/4. So then this 8 can be renamed as 7 4/4. 4 minus 3 is 1/4. So the difference in shoe size is 1/4 of an inch. Okay, letter E. Compare the shoe size of Ben and Frances. Okay, so if we look at our chart, Ben, right, Ben over here. Okay, so Ben is 7.5. And we remember we changed it, or we renamed it to 7 2/4. Okay, and we have to compare that to Frances. Over here, Frances. And Frances on our chart is 7 3/4. Okay, so we have Ben and Frances, and we need to compare. So since we already did the conversion when we did our chart, all we need to look at is the 7s are the same, and then I look at my fractions. 2/4 is less than 3/4. So 7 1/2 is smaller than 7 3/4. Okay, letter F. How many students had shoes that measured less than 8 inches? So if I just take a look at my chart, all I need to do is count how many were less than 8. So if I count, I have 1, 2, 3, 4. I have 4 students that have less than 8. Okay, and letter G. How many students measured the length of their shoes? So again, I look at my data information chart here. All they want to know is how many students are included in this chart. Well, I just count them up. I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 students who participated in that survey. And the last question, Mr. Jones' shoe length was 25 and 2/10 of an inch. It's Mr. Jones. And we have to use greater than, less than, or equals to compare the length of Mr. Jones' shoe to the length of the longest student's shoe size. So if I look at my chart, the longest student's shoe size was 8 3/4, and that was Mary. So we have 8 3/4, and that was Mary. So we need to find out who had the longer shoe. So we have to compare these. Now, in order to compare these, I'm going to rename the fraction as a mixed number by decomposing it into two parts using a number bond. So first thing I'm going to do is decompose. So 25 halves. Let me rewrite that. It looks like this. 25 halves. Easier to see it this way. 25 halves we need to rename. So how many halves are in 25? So if I count by twos, how many halves can I have out of 25? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24. 24 halves, and that will leave me with 1 half. So I can decompose 25 halves into 24 and 1 half. And now if I take 24 halves, that would give me 12 whole and 1 half. So 25 halves is the same thing as 12 and a half. And if I compare that to Mary's, well, I already know that 12, the whole number, 12 is larger than 8. So Mr. Jones' shoe head is larger than Mary's. So who had the longer shoe? Mr. Jones had the longer shoe. I hope this helped you. Thanks for listening. Bye.